we're going to quickly get started here. We are on part 2. Part 2 is talking about your symmetry of your function. Okay. The terms even and odd describe symmetry that exists for the graph of a function. Not only are we talking about even and odd degrees, but this is what you're saying, even and odd symmetry. It's saying, how is your function behaving? Okay. So an even function is even if and only if when the point x, y is on the graph, then the point negative xy is also on the graph. So an example of that would be if I have x, f of x, and it says, what is it? Brain fart. Negative 1, 1, 0, 0, 1, 1, right? Notice that at x equals positive 1 and at x equals negative 1, they have the same what? Y values. So this table is demonstrating that this function is possibly even. Does that make sense? Okay, so opposite x values have the exact same y values is what that's stating. All right, that makes it even. Okay, when you're looking at it graphically, your even functions are going to be symmetrical with the y-axis. Symmetrical with y-axis. Okay, your odd function. So a function is odd if and only if when the point x, y is on the graph of f, then the point negative x, negative y is also on the graph. Okay, what that would look like is if I have x, f of x, and I have negative 1, 0, 0, 1, 1. Not only are my x's opposites, but so are my y's. Do we see that? Same number, but opposite signs. So therefore, this is modeling an odd function as a table. Yes? Do we see that? Okay. This has what we call origin/rotational symmetry. Sounds familiar? Oh, yeah. Okay. It has origin/rotational symmetry. What that means is it goes through the origin, and if I was to rotate my paper 180 degrees, my graph would be the same. Ringing some bells, a little bit, a little ding ding happening. Bless you. Okay, so we're going to look at it graphically and double check that we understand what the graph means. Cool? So graphically, we have here A, B, and C. And we're going to determine what is odd, even, or neither. Okay, so if you look here at A, first off, what do you think it is? Odd. Because it goes through the origin, the first thing you should check for is it odd? So it goes through the origin. I have opposite values. So at negative 1, 2, I'm at 1, negative 2. And if the value right here goes through 0, 0, origin. It's an odd check, not a, well, if it's odd, you check. Odd has origin symmetry. So part of being odd, we're checking to see, does it go through the origin? If it doesn't go through the origin, it automatically can't be odd. So if I'm not going through the origin, whether it's an asymptote or anything, if I don't go through the origin, then there's no chance I'm even odd. Because you can have an even function that doesn't go through the origin, but you cannot have an odd function. Okay. All right. Now, if you turn your paper 180 degrees, does it look the same? Yes. So this tells you that this is a odd function. Okay. Your y-axis, your B is an example of an even function. That's because it is symmetrical with the y-axis. I create two even halves. Hence the word even function. I create two even halves. The opposite x values have the same behaviors. Did we see that? You can test even, but you can't assume it's even, because I cannot go through the origin, but I can also not be even. Because I could be not even with the y-axis. It could be neither. Yeah. So this is an even function. All right. So here I'm like, oh, this one goes through the origin. So I'm going to check odd first. Well, after I check the odd behavior, I'm like, oh, wait. At negative 1, it's at 0. At 1, it's also at 0. Okay, cool. But at other values, is this still matching up? No. And last check for odd, if I rotate my paper Does that image still look the same? It does not. Okay, so this is not an odd function. It is definitely not an even. So therefore, it is neither. So here's an example of all three. How do you feel about being able to graphically identify odd, even, or neither? Or recall being able to do that? Yes? Okay. Did it dust off some cobwebs on previous learned knowledge? All right. Next is, how do you do it algebraically? Algebraically means we're not using a graphing calculator. Algebraically means that we're going to do it by hand. So algebraically, what you're testing for is your how is your negative x performing? Okay. So if your negative x is producing a value that's the same as your positive x, then we are even. So I'm going to write it out. So if f of x equals f of negative x, then it is even. That's because you're saying if my opposite x's make the same value, then it is an even function. Does that make sense? No, you're going to plug in just x. Like, you're just going to plug in the value of x. Like, if it looks the same, just let me do it. You're not going to plug in no numbers. There's no numbers being plugged in. Okay. When we're testing for odd, we're looking for if f of negative x equals negative f of x. They're opposite. You're not plugging in actual x values. You're only plugging in x, okay? So the first thing you're going to do is you're going to find f of negative x. When you're finding f of negative x, that means everywhere there's an x, I'm changing it into a negative x. Here's an x, here's an x. And so I have negative x squared plus negative x minus 12. And I'm going to simplify this. Well, a negative times a negative is still going to be a positive. A positive times a negative is a negative. And I have negative 12. So the first thing I'm at is that x squared minus x minus 12 is what my f of negative x is. If it is different from the original, that means that it is not even. So this was my original. This was the OG. This is now my negative. Are they the same? No. So therefore, it's not an even function. Okay. I'm not even going to test for odd because what is the degree? It's squared. So my degree is also a key to help me know, do I need to test any further? No. So because the degree equals 2, I don't need to test for odd, and therefore this is going to be a neither. Because if I have a quadratic, it's going to either be doing this either way, right? It's going to be doing even in behaviors. So therefore, it can't even, if I flip it, it's going to be different. Yeah. Okay. It's because the degree is even. Exactly. Yeah, exactly. So here on this one, with that same knowledge here, before I even test, I'm going to do f of negative x, but I know I'm going to have to do another step to test for odd because it is a odd degree. Does that make sense? Is 5 odd? So this is an odd degree polynomial. So I'm going to have to do this and plus another step because I have to find f of negative x and negative f of x. So when you're testing for odd, you have to do both of these. So first we're going to find our f of negative x. Again, that means I'm just substituting in for x, not plugging in numbers, but plugging in the variable. So we have negative x to the 5th minus 4 times negative x to the 3rd. You have to have, for both of them, they require you to test for. Yeah, for both they require. That's why it's always going to be your step 1. All right, so a negative times a negative times a negative times a negative times a negative is going to be a negative. So we end up with negative x to the 5th. And it's going to be positive 4x. Why? Because the negative 4 makes it. Exactly. Okay, so that is my f of negative x. Because it's not an even degree, I'm going to test negative f of x. And it's because why? It's not an even degree. When you have a negative outside of a function, what does that mean is happening to the function? What's flipping? The signs of every term is changing. If you have a negative outside the function, your signs of every term changes. I'm going to put triangle for change. I'm lazy. So when I look here to find negative f of x, instead of it being x to the positive x to the fifth, it's going to become negative x to the fifth. Instead of being negative 4x to the third, it's going to become positive 4x to the third. If it's odd, then these two things are the same. Are they the same? Yes. So therefore, this is an odd function algebraically. The what? So when you have a negative outside of your function, it's telling you that the signs of every term is changing. So when I go to the original, my first term is positive, so it now is going to become a negative. My second term is negative, so now it becomes a positive. And because these two are the same, therefore this is a odd function. Yes.
So basically, the second step, you change the sign for the first one, like the first ever equation of change. Okay.
You change the signs of your original, your f of x, your original y. Okay. On the last one, let's do it really quick. We have y equals 2x to the fourth minus 6x squared. So the first thing we're going to do is find our f of negative x. So we have everywhere there's an x, it's going to become a negative x. So we have 2 times negative x to the fourth minus 6. Oh, fudge sickles. I may have to just change this pin up. Minus 6 times negative x squared, right? A negative times a negative times a negative times a negative is going to be a positive. So we have 2x to the fourth. Same thing here. A negative times a negative is a positive. So this is going to still be minus 6x squared. Exactly. So when we test here, it's a degree 2. That means that we just got to make sure that this and this are the same. Are they the same?
Yeah.
This equals this. So therefore it is an even function.
Oh, it even matches?
Because it matches the original. So odd matches your negatives. So if your negatives match, whether the negatives on the inside or the outside, that makes it odd. Your even is your negative matches your original. No, my niece.